Hi, my name is Grant, and thank you for watching the NX Series product video. In this video, we will be discussing the NX Series torque control as well as tension control modes. Some of the main features of the NX Series are its 4 selectable operating modes: the positioning control mode, the speed control mode, the torque control mode, and the tension control mode. It has the ability to drive high inertial loads without the need for gain tuning. With its auto-tune feature, it can drive inertias with the ratio up to 50 times. It's possible to drive an inertia ratio up to 100 times with manual gain tuning. It also has a high torque accuracy, which is 3 times better than our previous model. It also has an absolute system available with the use of the optional battery pack. It has a high output, high precision planetary gear option available, with a backlash rating of 3 arc minutes, an angle error of 4 arc minutes, and direct mounting capability. It also has the auto motor recognition system. For the 50, 100, and 200 watt models, all use the same driver. The driver can automatically recognize which type of motor is connected to it. Therefore, it can potentially reduce the amount of inventory you would need to keep on hand. Before you is the system layout. You can see the motor with the motor connection cable and the encoder connection cable. Here on CN7 is our digital I/O connection signals. On CN6 are our analog I/O connection signals. We offer the OPX-2A or the MEX E02 software to internally change parameters in access extended functions. There are provisions for a regeneration unit, and again we offer an optional battery pack for an absolute configuration. Here's a closer look at the drive. Again, CN2 for the motor connection, CN3 for the regeneration terminals as well as main AC in. We have a protective earth terminal. On the bottom of the drive is our connection for our battery pack. CN7 for our digital I/O connection. CN6 for our analog signals. CN5 for encoder connection. And for the control module or software, CN4. Taking a closer look at the top portion of the drive, we can see the SW2 switch. The SW2 switch will be used to configure back and forth between the different operating modes. When switch number 2 is switched to the on position, and with switch number 1 on the off position, you will be in torque control mode. With both switch 1 and 2 on, you will be in the tension control mode. On the right side, notice an LED indicator strip. This will tell the user which mode they are currently operating in. There's also a power indication as well as an alarm indication. The SW2 switch or mechanical rigidity switch, in torque control mode, this function is not used. In tension control mode, it sets the minimum speed in simple control mode. However, when it's used in high function modes 1 or 2, it is not used. Both VR1 and VR2 potentiometers are used in torque and tension control mode. In torque control mode, VR1 sets the torque command value, while VR2 sets the speed limit. In tension control mode, the function is similar, and VR1 sets the tension command value, while VR2 sets the speed limit. We also have our TV1 connection, where this is where you will power in your main 24 volt for the I/O control supply. We also have our TH1 and TH2, which is from the regeneration thermal input signal, and then our MB1 and MB2, which is our magnetic brake control terminals. Here's a detailed pinout of CN6. On input 1 is a reference voltage command for the speed. This is again used in speed control, torque control, as well as tension control. It accepts a plus or minus 10 volt DC signal. There's also an input for the torque command. Meanwhile, we have analog voltage output for both the speed monitoring and the torque monitoring. The P reference is for when we're using an external pot for the reference voltage for the pot. Some of the main features of the torque control mode are its high torque accuracy. It also has a low torque ripple via an optimized circuit that reduces the ripple. The user is able to select between a couple of different configurations. They can select between 2 analog input signals plus 6 digital signals or settings, or 8 digital settings are available. We can also limit the speed while in torque control mode. The VLC output will output when we have reached the set speed. We also have the TLC output, which will determine when the reached torque has been met. At this time, I'd actually like to show a demo unit to demonstrate the torque control mode. Before you is a 200 watt NX series AC servo motor. We have the dedicated drive, an SCX10 controller, which we are currently not using because it is in torque control mode, and we have an OPX digital operator. On the other side of the board is an AR closed loop stepping motor system, which does have similar type performance to the NX servo motor. And on the far side is a control board that we're using to control the signals for the NX while in speed control mode. On the bottom right hand side of your screen there is a switch button. Feel free to switch back and forth between the whiteboard and the video feed at your convenience. Right now, the NX is set to be running via internal potentiometers. So I've set both the torque and the speed limit via internal pot. I've set the torque low enough to where I can stall the motor by hand. Currently, on the OPX1, we are monitoring the torque. As I stall the motor, it will display the amount of torque, its output percentage. So right now, the output percentage of torque is at 57%. With the OPX, we can also monitor the speed. Currently, it's running at 22 RPM. Now, I can adjust the speed via the onboard potentiometers. With VR2, I'm going to adjust the speed up. And with VR1, I'm going to lower the output torque by making a small adjustment. Going back to the OPX, we're currently monitoring the speed. It's set to about 474 RPM. I click the down arrow, we can see the output torque. When I stall the motor, we can see that it's set to about 28%. Not only can you set these limits via onboard pot, you can switch over to set via external pot. We can also set using digital settings. On the main control board, I'm going to switch the M0 and M1 inputs to a high state, therefore activating data setting number 3. On data setting number 3, I have the RPM set to 10 RPM with a torque limit of 25%. So you can see the motor is running very slow at around 10 RPM. And when I stall the motor out, we can see that the limit is at about 24%, 25%. I've stalled the motor out. We can see that the revolution, again, returns to 0. And the torque is at 25%. Some of the overall torque control characteristics. With the NX series, it has a torque accuracy of plus or minus 5.6%. This is the amount of deviation between driver to driver. The repeatability, however, is plus or minus 0.23%. We can see that this is a slight improvement over the AR series, which is plus or minus 2%. And then over the BX series, we can see that it's a great improvement, which was plus or minus 10%. For the NX series tension control mode, the NX is capable of automatically tensioning or winding or unwinding an application for the user, effectively eliminating the need for a transducer or a dancer arm mechanism. It's able to maintain a constant tension. It can do this in 3 different ways, with a simple speed and tension adjustment setting, or more sophisticated ways such as material thickness, diameters, and core diameters, or inertia values. At this time, I'd like to show a demonstration video showing this feature. Again, feel free to switch between the PowerPoint presentation and the video as needed. The NX in this situation is in tension control mode. It's winding up this reel as it's being pulled through this assembly. You'll notice there's an actual transducer measuring the amount of force being applied as tension. It's consistently running at about 3 newtons of constant tension, located by the indication on the bottom of the screen. The NX is able to do this via a couple of different methods. There's more advanced methods where we would actually set a material thickness, an initial diameter, and a final diameter. And there's more simplified methods where we would simply set a tension and or a speed. In order for the user to do this, they can utilize either the OPX or the MEX software. In order to further understand it, I would now like to showcase the MEX software via desktop sharing. Please allow a moment for the desktop sharing to start. On your screen, you can see a copy of the MEXE software. You can see it's laid out similar to that of a normal spreadsheet. Through simplified commands, we can set a speed limit and a tension percentage command. Underneath the System Operation tab, we can select the 3 different methods of operation. The default setting is the easy operation. This is where we would set a tension command and a speed and simply run it. There's 2 other advanced functions, Advanced Function 1 and Advanced Function 2. With Advanced Function 1, looking at our operation data, we would actually apply an initial diameter, a final diameter, and a material thickness. With the advanced setting number 2, we can input even more information. We can input an inertial core inertia moment, as well as material inertia moment. We also have a taper setting percentage setting. This allows the motor to not over-tighten or tension when necessary. When set at 100%, it will run at a constant tension. However, when setting it in variables of percentage, the user has the ability to lower the overall tension as the diameter were to increase in a take-up reel type application. The material thickness is in micrometers and the diameters are in millimeters. Inertia moments are going to be in kilograms meters squared. Underneath the I/O setting, we can change between different output signals. For output switch number 1, we have the warning, move, or NBC output option. For output signal switch number 2, we can switch between the ZSG, which is the encoder output option, or the zero velocity output option. This lets the user know when the velocity has reached a set speed. The range of zero speed output will be in RPM set here. So when the RPM is reached at 10 or whatever this is set to, it will output the ZV output. For the analog settings, we have a number of different settings that we can utilize when using analog signals. We have an analog speed limit gain, an analog speed limit clamp, analog speed limit offset voltage, analog tension gain percentage, analog tension command offset voltage, an analog input signal offset, and many others dealing with analog voltage command. We also have some basic alarm and warning settings, such as an overvoltage, undervoltage, overheat, overload, and overspeed. Underneath the function, we can set an accel-decel correction filter, which is in milliseconds. We can also input a friction torque correction percentage to overcome any mechanical type load. The deacceleration rate of the speed monitor is basically an external gear ratio input. The manual operation display. This is set for the operation tension of the jog command and also the displayed speed for the OPX. We can also turn on OPX editing or disable that function. Electronic gear of encoder output A and B. This is electric gearing or simply changing resolutions of the output for the encoder. Again, going back to the operation, this is where we can select between the 3 different methods. Also our tension control deacceleration ratio, again the external gear ratio. We can enable or disable analog input signals and change the rotation direction of plus or minus, or clockwise or counterclockwise. Under status, we can actually view the current status of the motor, the actual speed, the actual torque percentage, the tension command, the operation number, and selection number. Another thing to note, under operation, you do have 8 different settings that you can input for 8 different type tensioning applications. We can also monitor the I/O, as well as some of the analog signals. Under the waveform, this can be used to troubleshoot and diagnose specific applications or circumstances, where we can actually monitor outputs and overall performance waveforms. And then finally, under the test, we can test a different I/O as well as analog I/O. And then under operation, we can again view the actual speed and torque, clear alarms, and manually jog the motor into position. As you can see by the characteristics shown below, it is possible to set a minimum speed and start a steady tension control. The torque characteristic varies inversely with the motor speed. It's capable for steady tension operation depending on the roller diameter in variation of a winding application. So again, by inputting some initial data, the NX does have the ability to automatically change its speed and tension as necessary for a wind and unwind application, therefore possibly eliminating external components and saving overall space and or money. If you have any questions, feel free to contact us at 1-800-468-3982 or email us at techsupport@orientamotor.com. For more information on the NX series servo motor, feel free to browse other product videos. My name is Grant, and thank you for watching.